All right, finance students, let's work on practice problem 6.3. Now we are looking at annuity dues. We've previously been looking at ordinary annuities, which is under the assumption that we are getting our annuity payments at the end of the compounding periods. Now we're going to look at annuity dues, where we are assuming we're getting the payments at the beginning of our compounding periods. Okay, so now one change that we have to do, that type option that we've been seeing in our future value, present value functions, we are going to have to use that. It's very simple. An ordinary annuity would be a type 0, or you could leave it blank. So you can remember that as O and 0 are pretty much the same thing. And an annuity due is a type 1. And you can remember that with a 1 being the first period, the first payment period at the beginning. 1 is the beginning. Think it that way. So let's do the first two of these, and then you can work the other two yourself. For the first one, what's the present value? So we're looking for present value of $1,000 at the beginning of each of the next 3 years. So it's a $1,000 annuity payment at the beginning of each of the next 3 years if your discount rate or your opportunity cost is 8%. So we're looking for present value. We know our interest rate is 8%. We know number of periods is 3 years. We know our payment would be $1,000. And we have no ending value, nothing that we are looking for adding in, so that would be 0. Now the other thing, if we have beginning here, this is actually a type 1 annuity. So now when we run our present value function, our PV function, we plug in our rate of 8%, we plug in number of periods of 3, our payment of 1,000, our future value of 0, and now we include a type 1. Notice, when we get to that option here, type, it says, hey, is this a type 0 or a type 1? Is this at the end of the period, an ordinary annuity, or is it at the beginning of the period, a type 1? And we have a type 1. So once we have that, we close our parentheses, we hit enter. And what we find is we would have a present value of $2,783.26 for this annuity due. Let's do the next one. How about this? What if you invest $1,000 at the beginning of each of the next 3 years at 8%? How much would you have at the end of year 3? So this would be a future value. How much would you have at the end of year 3? So this is asking you for a future value of an annuity due. So let's plug in what we know. There's no present value. My interest rate is 8%. My number of periods, 3 years. My payment, again, is $1,000. We're looking for my future value, but since this is the beginning, we know this is type 1. So now that we have all of our inputs, we can run our FV function for future value. Rate is 8%. Number of periods is 3. Payment is $1,000. My present value is 0, so I'm going to leave it blank. And my annuity is a type 1. We hit enter. So I see that the future value of an annuity due of $1,000 would be $3,506.11. Go ahead and work on the last two problems for this one. This gives you a good idea of comparing ordinary annuities, payment done at the end of a period, and an annuity due, what the difference is. If you realize what you're getting, if you have an annuity due, you're actually making a payment earlier on, so you should be getting all the interest accumulated for that first period. So the idea is the value at the end of an annuity due should be higher than the value of an ordinary annuity if it's the same payment, same interest rate, same time period. But I'll let you calculate those yourself.